In today's lesson, we're going to start talking about sampling and bias, which is an introduction to statistics. So we are starting statistics. And sampling and bias kind of revolves around how to gather people to do your study. And then the bias part is what to be careful with when you're actually doing the study and when you're selecting the people for your study. Okay, so we're going to start with the beginning of statistics. What is statistics? Well, it's a science, and it's the science of collecting, analyzing, and drawing conclusions from data. So we're going to talk about how to collect your data, how to look at your data to see what it's telling you. And then if you move on and more into statistics, you'll learn how to draw conclusions from your data, if you can get conclusions from it, which you'll learn that not all data you can get conclusions from because there could be bias. All right. And so there's two major branches of statistics that you will eventually talk about if you go into that field. One of them is descriptive statistics, which is what we will concentrate in this class a lot on. And that's organizing and summarizing your information. So that would be like how to graph your data, how to make tables from your data, and some numerical techniques like doing some calculations with your data to be able to observe and analyze it. And then you have what's called inferential statistics. And inferential statistics is where you actually start estimating things and trying to make decisions based on your data. And then you look to see, can you generalize that data from the sample that you've taken to the whole population? And that's the hard part of statistics, is seeing if you can actually make it generalized to the population. Like, if this is true for the sample of people that I've taken, is it true for my whole population? All right. And if you go more into statistics, you will actually start doing more of that. All right. So let's start talking about, where does this whole thing get started? Well, it starts with what's called the population. All right. And so population has a definition. It is the entire collection of the individuals or objects, because, you may not be doing a study on people, you might be doing it on things or objects, but it's the entire collection of those people or the objects about which information is desired. So who, in other words, are you interested in doing the study on? Okay, so that's an easy way to think about population, is it's who or what you are interested in doing the study on. So who are you wanting to study? Okay, so that's a good way to think about it. So now, after you figure out who is it that I'm wanting to do my study on, or what is it that I'm wanting to do my study on, you're going to gather your information from the people, and we'll talk about how to do that a little later. And after you gather your information, you start doing calculations with it. Any calculations that you do with the entire population, any calculations that you get from the whole group, are called parameters. Okay, so this is just a vocabulary word. So parameters are any of the measures that you've taken from the entire population. And to represent this, you're going to notice that they're going to use Greek letters for that. Okay, so like your sigma that we had talked about before, that's like a Greek letter. So you're going to start seeing Greek letters, not the normal letters that we use when you're dealing with the population. All right, and so there is a name for it when you collect data from every single person in your population, and that's called a census. And you might have heard of the U.S. Census, which we actually have this year. The U.S. Census is where they collect information, or they try to collect information from every person that lives in the United States, for purpose of making decisions in the government and all of that. And so a census is when you actually are literally trying to get information from every single person that you're interested in doing the study on, which you'll notice is actually very difficult. Okay. And so the reason why you would want to do a census and actually study everybody in your population is it allows a question about the population to be answered. So, like for instance, if they give the U.S. Census, and one main purpose of it is to figure out how many people are living in the United States. If they were actually able to collect it from every single person that lives in the United States, they would definitely be able to answer the question, how many people live in the United States? But as you kind of start thinking about this, you'll notice that it is actually very difficult to make that happen. One reason is because it could be very, very expensive. Like if they send a letter to every single person in the United States, that could get expensive because it's expensive to send letters, to every single person. Something else is if you're doing a study, it could be impractical or it could be impossible. So, like another example would be let's say that I am a medical doctor and I am doing a study on some particular type of cancer. And I have developed a medicine that supposedly cures a certain type of cancer. So then, well, who would I be interested in doing my study on? It would be whoever has that particular type of cancer. So my population would be whoever has that cancer. And then I would, if I could test it on every person in the population, I would, but you're going to notice that that may not be possible because some people may be a little weary about testing a new drug on themselves because it could cause more harm than good. You may have some people that pass away before you can actually test it on them. That would be part of your population because remember, your population is whoever has that particular type of cancer. And then, sometimes, there's people in other countries that have the cancer and you just can't get to them. And so, sometimes trying to test something or do a study on the entire population may not be a possibility. Okay. And so that's the reason why we have what is called a sample. All right. So just remember, the population is the entire group of people that you're interested in doing the study on. And if you can do it on the entire group of people, then go ahead and do it. But if not, then what you're going to do is you are going to take a sample of people. And so now let's talk about what a sample is. A sample is part of your population. So if you can't do the study on the entire population, then you are going to take what's called a subset or part of your population out of the whole group and then do the study on that group of people. Okay. And so the sample is the group of individuals or objects that you've actually chosen to get information from because remember, you couldn't do it on the whole population. And so the way that I kind of think about it is it's those that are actually picked to be in the study, the survey, or the experiment, whatever you're doing. Okay. And so if you're collecting a sample of people or things to do the study on, after you actually collect your data, you're not going to call the measures parameters anymore. You're going to actually call them statistics. And that's where statistics gets its name. So statistics are any of the measures or any of the data that you've collected and taken from a sample of people or things, okay? And so they're going to use English letters for that. And so you're going to be used to seeing those types of letters, right? So a sample is when you've taken a part of the population out, all right? So just to give you an example, let's say that at your school, they're wanting to do a study let's say they're trying to find out if people are interested in doing a fundraiser to raise money for to get a brand new band or chorus room at your school. Well, the study would be every person, or you would want to study every person that goes to your school. So the population would be every student that goes to that high school. And then if for some reason they are not able to get, you know, every single person to participate in that study, they might take a sample of people out. And so the sample of people would be, you know, let's say I randomly choose a bunch of people, like 100 people from our students from the school to study. Well, that would be a sample because I didn't include everybody that goes to the school. I just included and picked randomly a group of students from the school. Okay. And so that's kind of an example relating this population and kind of comparing it with the sample. All right. And so, well, using a sample of data rather than the population, it will make it more practical. It'll make it a little easier than doing a census. So, like, you don't have to collect data from as many people. So it makes it a little easier on you than doing a census, which would be collecting it from the whole population. The only problem is when you do a sample, when you take a smaller group of people, it's going to give variable results with some possibility of a wrong conclusion being adopted. Well, why would that happen? Well, let's say that you take a sample of people, and going back to my example where it asks, you know, if people are interested in doing a fundraiser to raise money for a new band room or chorus room, let's say that in my sample, for some reason, you know, for some crazy reason, my sample ends up having a lot of band and chorus students in there. Well, what kind of answers do you think I'm going to get for that? Yeah, of course they're going to want a new band and chorus room. So that may not truly reflect the opinion of all of the students at the high school. And so I may come up with a wrong conclusion compared to what the whole population wants, okay, or the whole school wants. All right. And so you've got to be careful when you're taking a sample of people. You really want it to truly represent the whole population that you're interested in doing the study on. Okay. And so that's what we're going to kind of spend some time talking about is how can you get a good sample of people or things? And then also some things you want to look out for in terms of bias. All right. So let's start talking about samples. All right. There's a bunch of different ways that you can take a sample of people or things to do your study on. And some of them are good and some of them are not so good. And so we're going to talk about it. All right. So these are some good ones. So a simple random sample, which sometimes you'll notice is shortened as SRS. A simple random sample is the same thing as if like somebody took a bunch of people's names. Like if I took all the students at your school and put their name on a slip of paper and put it in a hat and randomly drew out names, that would be a simple random sample. So this is one that where the sample that is selected, it's selected in a way that ensures that every different possible sample of a certain size has the same chance of being selected. So if you're making it to where everybody has an equal chance of being selected, then that's a simple random sample. So for those students that are in my class, I do simple random sampling every day when I do my popsicle sticks because everybody's name is on a popsicle stick in each class, and they all have an equal chance of being pulled. Okay, and so anything that truly randomly allows people to be selected so that everybody has the same chance of being selected, that is a simple random sample. Okay. And so two things that you want to consider whenever you're doing a simple random sample is the sampling frame. The sampling frame is just a list of all the students or all the people that are in that population. So it's a list of everyone in the population. So if you're going to do this, you want to make sure that you include everyone. Okay. So a list of everyone in the population. Okay. And then something that we talked about that you have to be careful of when you're doing this, especially if you're doing like probability with it, is sampling with and without replacement. So like if you take somebody's name out, then notice there's going to be one less person in, like if you have their names in a hat, there's one less person in the hat to be drawn. So that does affect the likelihood of the next person being drawn. And so you want to consider that whenever you're doing simple random sampling. Okay. So another way, and I'm going to actually talk about the next two kind of together in a little bit, but another way of sampling is what's called stratified sampling. All right. Stratified sampling is where you're going to take your whole population, the whole group of people that you're interested in doing the study on, and you're going to separate them into subpopulations, which is called strata. This is where you just separate them into groups. And so, like, if you were at your school, you guys are naturally separated into grade levels, and so the strata could be each grade level. And so I'm going to go to the side here. And I'm going to say, okay, let's say that we have our 9th graders, we have our 10th graders, we have our 11th graders, and then we have our 12th graders. So that would be like your strata, okay? And so if I'm going to do stratified sampling to figure out who I'm going to do my study on, then what I'm going to do is I'm going to select a separate simple random sample from each strata. And so I know that's kind of using some new terminology here, but all this is saying is if I'm going to do a stratified sampling, so stratified sampling, then what I'm going to do is I'm going to select a certain percentage of people from each group. So you separate them into groups. And then after that, you select a certain percentage of people in each group. So like, let's say, and usually you'll do it relative to how many are in each group, but we're not going to get that specific here. So let's say that I decide I'm going to select 25% of the people from each group. So that means I'm going to look at my list of 9th graders, and I'm going to figure out what 25% of that is. Like, let's say that there were 100 9th graders, just to make the math easy. So then I would be selecting, 25% of 100 would be, I'd be selecting 25 9th graders, and I'd randomly pick them. So make sure you're randomly picking them. And we just talked about you could put their names in a hat, or you can assign numbers to their names and use a random number generator to choose your people. And then I'm going to choose 25% of however many 10th graders there are, 25% of the 11th graders, 25% of the 12th graders. And so the way that you can think about stratified is you're choosing a smaller group out of each one. So that's kind of a way to think about it, is I'm choosing a certain percentage out of each group. Okay. So stratified, you're separating them into groups, and you're choosing a small group of people out of each of those groups. All right. So that's stratified. Okay. So cluster is going to be similar, but you're going to notice that there is a difference. So cluster sampling, you're still going to put them in groups. All right. So the entire population is divided into non-overlapping subgroups. Okay. And so non-overlapping just means that you're not going to have a person in 2 of the groups. You want to make sure that there's no 2 people like in the same group, or I guess there's not one person that's in multiple groups. So like grade levels, that wouldn't happen because there's not a person that would be classified as a 9th and a 10th grader, if that makes sense. And so cluster sampling, you're still dividing them into groups, but this time you're going to select, and the groups in this case are called clusters. And so in this case, you're selecting entire clusters at random, okay? And all the individuals in those selected clusters are included. So the difference here, just so we can go back to our example, is with stratified, you're picking a smaller group out of each group. With cluster sampling, so I'm going to go down here and do the cluster sampling. you're going to have your groups, but you're going to actually randomly pick entire groups. And so if I was doing this example, instead of picking a small group out of each one, I'd literally put in a hat 9th, 10th, 11th, and 12th. And then I would randomly pick a couple of those groups. So like if I put in a hat 9th, 10th, 11th, and 12th, if I randomly pulled out 10th and 11th, then I would include the entire 10th grade and the entire 11th grade in my sample. And you'll notice that wouldn't be good because the 9th and the 12th graders would be left out. And that you're going to find out in a little bit that that's going to make some bias in our sample. And so with this example, you would actually want to do stratified sampling. So then when would you want to do cluster sampling? Well, instead of dividing the school maybe into grade levels, you could separate them into their homerooms. And so we would have, Miss Morgan's homeroom, and then you'd have Miss Beard's homeroom, and then you'd have Miss Starnes' homeroom, and then Mr. Taylor's homeroom, and then Miss Rabinowitz's homeroom, and you'd have all the homerooms. And remember, there's multiple, like to 9th grade homerooms, there's multiple 10th grades and everything like that. And then after you have all your homerooms, you'd randomly put, you'd put their names, like each homeroom teacher's name in a hat, and you would randomly choose homeroom. So like, let's say that I randomly, after I put their names in a hat, I picked out Miss Beard's homeroom, Miss Rabinowitz's homeroom, and Mr. Taylor's homeroom. What I would do is I would survey and do the study on their entire homeroom. Okay, so you're not picking a small group out of each group anymore. You're actually picking the entire groups to do the sample on, okay, or to include in your study. All right, so cluster sampling, you're dividing it into groups, and then you're picking the entire, like you're randomly picking entire groups and including all of the people in that group to be in your study, okay? And so this is just kind of emphasizing what I just said, stratified versus cluster. With stratified, the sample consists of some of the individuals from each of the strata or each group. And then with cluster sampling, the sample contains all of the individuals from every one of the selected clusters. All right, so you're going to select whole groups to be in your sample. All right, so those are some really good ways of sampling. We discussed, some are better than others in certain situations. And so now we're going to talk about other ways of sampling. Okay, so another way of sampling is what's called systematic sampling. And this is one where you would be able to use it if you can put the people that you're interested in, or the population, if you can put it in some type of list or some other sequential arrangement. So like if you could take people's names and put them in a list, you'll be able to do this way of sampling. But if you can't put them in a list, then you wouldn't be able to do this, okay? But the way that this one works is you're going to sample, and you're going to randomly choose somebody to start with. So like I would randomly choose a number, and I would count down my list until I get to that number. So the one of the first K individuals is selected at random. So let's say I randomly choose the number 3 to begin with. Then I would look at my list of people. So here's my list of people. And then I would count down, and I would start with the third person on my list. And then you could go from there, every third person, and include them in your sample. Or you can randomly choose another number. Let's say that I randomly choose the number 2. Then after that, I would go and count 2 people. So start with that person. 1, 2. That person would be included in my study. Then I'd count 1, 2. That next person. So a simple way of thinking about systematically sampling is you're choosing every kth person, or sometimes you'll hear some people will say every nth person. So if I'm doing a sample of your school, I could list every student in the school, and then I could choose a random number. So let's say I choose the random number 5. then what I would do is I would go down the list of the names that I have, and I'd include every 5th student to be part of my study. Okay. And so systematic sampling is choosing every nth person to be in your study. Okay. But you have to select that number randomly. And if you're wanting to choose like a certain percentage of people, you would have to be specific about that number, but you still want to be random as much as you can. All right. The last way of sampling is probably the worst way of sampling. And so this is one that you would not want to do unless you have no option. Okay. But the results from this may not be good, but it's called convenient sampling. All right. And this is using an easily available or convenient group to form a sample. So like, for instance, if I was wanting to know what people's favorite clothing store was, and I'm walking out of, I don't know, Belk one day, and I ask people what their favorite clothing store is as I'm kind of walking out of Belk, then, I might have a little bit of a biased response because they might like Belk. And so that would be an example of convenient sampling because it's just doing what's convenient to you. All right. So if you're doing something that's convenient and you're not truly trying to randomly sample people for your study, then that's convenient sampling. Okay. And so a form of convenient sampling is called voluntary response sampling. And this sometimes can't be avoided, but you want to try to not do that as much as possible. The voluntary response is what it sounds like. These rely entirely on individuals who volunteer to be part of a sample. And so, like, if you respond to an advertisement or you call a publicized telephone to give your opinion about something, or like, for instance, all those surveys that you do about products that you buy online, those are all voluntary response because you have to literally volunteer to go in and do the survey. You have to, you kind of volunteer yourself anytime you call in to give your opinion about something. And so anytime where people have to actually volunteer to do something, you're not made to do it, then that's a voluntary response sampling. And that's not always good because think about, for the surveys, most people don't really want to give their opinion about stuff unless they feel strongly one way or the other. Most times you either love the product, so you want to tell people how good it is, or sometimes you absolutely do not like the product and you want to tell people how bad it is. And so that's not always a good thing because not everybody is being represented with their opinion. Okay. And so these are all types of convenient sampling. All right. And you want to avoid that as much as you can. All right. A lot of medical studies and psychological studies have to be voluntary because you can't subject people to medicine unless they actually volunteer for it. And so like I said, sometimes you can't avoid it, but you want to try your best to avoid it as much as possible. All right. So that's all the ways to sample people, to select a group of people to be part of your study. So now we're going to talk about some things that you want to be careful about when you're doing your study and when you're sampling people. Okay. And that's the concept of bias. All right. So let's start talking about what does it mean to be biased versus unbiased. So when you're selecting a sample, your goal is to get what's called a representative sample. So a representative sample is any sample that gives you a good idea of what the population is like. Because remember, this is when you cannot do the study on the entire population. So when you select a sample of people, you want that sample, that group of people, to represent your population as much as possible. So a sample will be biased if, for instance, it does not represent the whole population. Like there are certain people that are left out that need to be represented. So, for instance, like with my band and chorus room example, you'd want people that are in band and chorus to be part of your sample, but you also want people that are not in that program to be part of your sample to get a true representation of the whole school. And then the other thing that you want to be careful about, because it'll be biased, is if you design your study in a way that's designed to favor certain outcomes, then you have bias in your sample. And so I would not want to go to the band and chorus room and just select people from that group to be included in my sample because you're favoring a certain outcome. You must be wanting, money to get a new band or chorus room, and that's not necessarily the point in the study, and the point was just to see if people were interested in it, okay? And so you want to be careful about these two things, all right? So for your sample to truly be what's called unbiased, the sample of people you select should represent the whole population, which is very hard to do, but you want to try to your best to get everybody represented in your sample. And then you want to design your study so that it does not favor certain outcomes. So you don't want to ask questions in a certain way that's going to lead people to certain answers. And you also don't want to select people that's going to give you a certain outcome. You want to truly get the whole group represented, okay? So let's talk about the different biases that you could have when you're doing the study, all right? So the first type of bias that you could have is what's called sampling or selection bias. And a type that you'll talk about is undercoverage. So if you choose your sample of people and you exclude certain parts or certain groups from the population, then you have what's called sampling bias, or you've undercovered your population. You did not include everybody that's in your population. So like, for instance, the U.S. Census actually has selection bias or sampling bias, because you'll notice the U.S. Census is sent to all the people that households in the United States. And so the homeless are actually left out of the U.S. Census. So that is a form of undercoverage bias, okay, which is not necessarily a good thing because, the homeless do live in the United States. And so you've got to watch out for that. So anytime you're excluding some group from the population of who you're interested in doing the study on, you have sampling bias or undercoverage, all right? Another form of bias that you could have is what's called response or measurement bias. So if your sample of people differ from the population because the way that you do the observation tends to produce values that are different from what truly should happen, then that is response or measurement bias. So to give you some examples there, let's say that, in my class, I just gave a test and I suspect some people cheated. Well, if I go up and I ask you, did you cheat on the test? Me being a teacher, you being a student, I'm going to get some response bias, because no matter whether you cheated on the test or not, you're probably going to tell me, no, I didn't cheat. And so response bias is when people are essentially lying to you. And it may be your fault that they're lying to you, like me being a teacher asking that question. That's not necessarily going to give me responses that are always true. So if I ask a question in a way, or I do a study in a way and design it to where people lie to me, or people just lie to me in my study, that's response bias, because it's different from what their truth is, okay? So if you get responses that are different from what the truth should be, then you have response bias, okay? Measurement bias is if you were doing a study that involved, like, I have an example down here, where like maybe you have to weigh people. Maybe you're doing like a study with weight loss vitamin or something like that. If you, for instance, forget to zero the scale, or you have multiple people doing the measurements, like people are measuring people's heights or doing any kind of measurements, if for some reason they measure something wrong, then you're going to have measurement bias. And so those are two different things that you want to look out for when you're designing your study, so that you won't have that type of bias. Another type of bias is voluntary response bias. Anytime people are volunteering to be part of your study, you're going to have this kind of bias in there, okay? So this is when the sample differs from the corresponding population because individuals volunteer themselves to be in the sample. So anytime, like I said, you have people volunteering to be part of your sample, you're going to have that in there. And you can't really avoid that, but if you can possibly do it without having people volunteer to be part of your sample, that's the way you want to do it, okay? The last type of bias you could have is non-response bias. This is when maybe I've sent out a study for all the people at my school to fill out and turn back in. If not everybody turns it back in, then I have non-response bias. So this is when people do not give you or do not participate in your study that you have selected to be part of your study. All right. So data is not obtained from all the individuals selected for inclusion in the sample. Okay. So the sample is not made of everyone selected because some did not respond or participate. So if you have some people that you've wanted to be part of your study, but they say, I'm not going to do it, then you have non-response bias. Okay. So please let me know if you have questions. There's a lot of resources online that gives you examples of all of this. So if you get lost in a question, just look up bias or sampling and you'll have all kinds of resources. Let me know if you have questions. Have a wonderful day.